All right, this lesson is about tessellations, and I have some tessellations on the screen here, and they are pretty cool, pretty artistic. What exactly are they, and what are we going to do with them? Let me go up one. So a pattern consisting of the repeated use of the same geometric figures to completely cover a plane, leaving no gaps and no overlaps. That's the key, and we're going to explore that and kind of show that there are no gaps and no overlaps, okay? The sum of the measures of the angles that come together at each vertex must always be 360 degrees. Now that's the key to this, okay? And in this class we will only be talking about regular polygons. So that is what are regular polygons. We've got shapes that have the same length sides and the same angle measures. So I'm thinking of a square. A square is a regular polygon. It's a good example, but you can have a regular pentagon. You can have any regular n-sided figure, okay? So in each tessellation, the same types of regular polygons surround every vertex, the intersection point. Remember, this point, that's a vertex. This is a vertex, if you can see my mouse. I have vertexes everywhere, and for a tessellation, if I have a tessellation, I'm going to have the exact same shapes coming together at every vertex. So the sum of the measures of the angles that come together at each vertex must be 360 degrees. Remember how a circle works, right? All the way around is 360. So if these pieces did not sum perfectly to 360, this would not come together without any gaps or overlaps. So that's what we're going to prove when we look at these figures. So let me continue. The sum of the measures that come together at each vertex is 360 degrees, which is a requirement for the formation of a tessellation. So you can see the zoomed in, right? What do I have here? I have a square, and then how many sides does this shape have? 1, 2, 3, 4, 5, 6, 7, 8. That's an octagon. So I have 2 octagons and 1 square coming together at this vertex, and we're going to use what we know about our formula for the sum of the angles in a polygon. Remember, our n minus 2 times 180, and we can figure out what are these 3 angle measures and do they add up to 360 degrees. And you will find that yes, 135 plus 135 plus 90 is going to give me 360, and that's what we're going to be doing. Okay, so we're going to have a tessellation. We're going to have 3 questions to answer. Number 1, we're just going to name the type of regular polygons that surround each vertex. So on this one, it would be nice to zoom in. You could go to any vertex, and I could just pick one randomly and ask myself what shapes are coming together here. I can see I have 2 squares, I have a triangle, and then this has 6 sides. 1, 2, 3, 4, 5, 6. It's a hexagon. So step 1 is we're going to just write down the shapes. So like we just said, if I pick a point, any vertex, okay, and I'm going to see what shapes are coming together at that vertex. I'm going to have a triangle, 2 squares, and then this is a hexagon, okay? So let's write that down. Question 2, determine the number of angles that come together at each vertex as well as the measure of these angles. So going back to my vertex, and you could pick any of them, I have 1, 2, 3, 4 angles coming together. So that's the first part, 4 angles. And what I need to do is I need to use my n minus 2 times 180 formula to figure out what are the values in each one of these angles coming together at the vertex. The square, I know, that's 90 degrees. I can tell you that real quick. The triangle I also know too, because this is a regular triangle, so, and they all need to add up to 180 degrees. So take 180 divided by 3, and you're going to have 60 degrees, okay? But this hexagon, I need to figure that one out. So I'm going to get some space to do that. All right, for my hexagon, I have 6 sides, so n equals 6. So it's going to be 6 minus 2 times 180. That's going to be 4 times 180. You will get 720. All right. But what I'm looking for, though, is what is the angle, that one specific angle here. Now, what I just found was the sum of all of these angles in the hexagon, but I just want this one. and they're all equal because it's a regular hexagon. So I can just take this 720 and I can just divide it by 6. Divide by 6 because I have 6 equal angles. Put it in the calculator. I get 120. So that's going to be one of my angle measures coming together. So what do I have? I have 120 degrees. I have 90 degrees, I have 90 degrees, and I have 60 degrees for the triangle. And you can figure out the triangle the same way if you didn't know that it was 60 degrees, that you could do n is 3 minus 2 is 1 times 180, and there you have it. You've got 180 degrees, and then divide it by 3 because there's 3 equal angles. Okay, so let's write this down. Okay, so there's my answer for number 2. Number 3, okay, is asking, use the angle measures from part 2 to explain why the tessellation is possible. What is that asking me to do? It's saying prove to me that those angles are going to come together perfectly with no gaps or overlaps, and they will sum up to a perfect 360 degrees. Okay, so you're just going to simply write, I know that yes they are, this is a tessellation, and you're going to say 90 degrees plus 90 degrees plus 60 degrees plus 120, and you're going to confirm it. Because what if I gave you one that wasn't a tessellation and then you thought you added them up and it didn't sum to 360 degrees? But in this case, it does. And so basically, we just did a mini proof to prove that it is a tessellation. Okay? So let me quickly show you this one. So what I have here are 2 hexagons. I counted up the sides, and 1 heptagon coming together in what appears to be a tessellation, right? So I do my n minus 2 times 180, and I'm going to divide by the number of sides. So that's where this is coming from. N is 6 for the hexagons. We just did this one. So it saved you time. I did it for you. That I should get 2 angles that are at 120 degrees, okay? Now the heptagon does not come out nice and neat. When I do n minus 2 times 180, divide by 7, because there's 7 equal sides in theory, I get 128.57. Now, if I tried to say, all right, let's prove that these 3 angles that are coming together at the vertex sum to 360, it is not going to work out. 128.57, that's not even a whole number, and when I do it, I get 368. Now, it's pretty close. 368.57. 57 degrees. Getting a little blurry there. So that's not a real tessellation, okay? So the whole point in our homework is to show that it is a real tessellation like we did up here, okay? Thank you. If you like the video, hit the like button and or subscribe. Thank you.